thank you for taking up this survey for us. Without much ado and not wasting much of your time anymore, we will delve into our webinar series today. My name is Sampzon Zickson. I am the West Africa Solar Lead for Jubaili Bros Solar, and I am situated in the Ghana office. I look after the business development and solar business across West Africa. We have another team in Nigeria that is strongly looking after the business development also in the Nigerian market. I am glad to join you today to have this webinar. This webinar is on the topic upgrading your optimizer experience with Huawei. Upgrading your optimizer experience. So welcome everybody, and I hope you'll be as excited and enjoy this as much as I will as we go along. Okay, so just a background on Jubaili Bros Solar. So Jubaili Bros Solar is 43 years in power solutions this year. We are actively present in 10 countries around the world where we have branch offices. We have 3 manufacturing plants also around the world, and we have 29 branches and service centers globally. We have over 1,300 employees worldwide and 70 dealers and distributors around the world. So this is our global strength in terms of staff and positioning for the past 43 years in power solutions. This year, last year 2020, coming into this year 2021, we have developed a new vision and mission for the company. The vision is to be a pioneer in delivering conventional and renewable energy solutions to our customers, like those of you who are listening now on this webinar. And it is very important it is for this vision that you can see that currently Jubaili Bros is also focusing on what we call the PV diesel hybrid systems, because we believe it's a bridge between the conventional and renewable energy solutions that we offer. We will touch more on that as we go along in this presentation. Our mission is to be a trusted partner to our customers in delivering reliable energy solutions through our dedicated teams and our global partners together. So that is our mission, is to make sure that you, our customer, trust us in our project deliveries to you. Moving ahead one, so let us talk about the milestones and the timelines of Jubaili Bros. Jubaili Bros started in Lebanon in the year 1977. Quite an interesting journey. And since 1977 in Lebanon, we have moved on. We have established ourselves permanently in the UAE, in Nigeria, in Afghanistan, Kuwait. In Ghana, we entered Ghana in 2010, where I'm located and speaking to you from now. We have also been in Qatar, Uganda, South Africa. So in 2017, if you take a look at our journey from 1977, in 2017, the company celebrated a huge milestone. We became 40 years old, and in order to commemorate that milestone, Jubaili Bros Solar Vision was actually outlawed as a form of commemoration of our 40 years in power solutions valley. And since that time, last year, despite the pandemic, we were able to also establish ourselves permanently in Pakistan. So currently, this is the history of Jubaili Bros and how Jubaili Bros Solar came to birth. So since 2017, the Jubaili Bros Solar Vision has been established. So a look into the Jubaili Bros Solar Division and our 6 key pillars for supporting our EPC customers. What makes us tick as Jubaili Bros Solar? What are the pillars that we rely on? The first and foremost is product supply, and the whole business of Jubaili Bros Solar is to position ourselves as smart PV product suppliers to our customers globally. The whole purpose is to make sure that we supply promptly and quickly and at very, very affordable prices to our customers. Aside this pillar, we also offer training services to staffs of our customers to ensure that they are trained amply and they are able to administer the products that we actually sell to them. We also offer engineering support in terms of project design, validating your designs that you do for your projects. This is also support that is offered by Jubaili Bros. And we also offer leads onto our customers. We leverage our wide market presence and our knowledge of industry players to offer leads to our EPC customers. We also offer referral to available finance. So you are a project developer, you are an end user, you buy equipment from us, we can actually refer you to our funding partners, and together we are a match made in heaven because we can make solar projects actually operationalize. And we also offer strong after-sales support to our customers. We don't just leave you after selling to you. We offer strong after-sales support in terms of installation, commissioning, O&M, advice, and all that. So these are the 6 pillars that make Jubaili Bros what it is. And we have always believed that these are pillars that can take us to where our vision is moving. Now, just to another steps milestone. So we are a one-stop shop for complete solar solutions, and you can see all our partners are industry leading partners. In terms of inverters and accessories, our key partner is Huawei. We all know for the past 5 years consecutively, Huawei has been the #1 leader in global shipments in terms of string inverters anywhere in the world. And also when it comes to the mounting structures, our key partner is Lumax. Lumax Energy supplies us mounting structures. And we have partnerships with tier 1 solar module manufacturers globally, and we do tier 1 only. And we, as I mentioned, we also have PV diesel solutions. So there's a PV diesel hybrid controller that we also use for our services. Mostly we do Combi, Deep Sea, and DEF. Okay, so let me delve a little bit into Huawei because this webinar today is particularly about the Huawei optimizers. So for Huawei, we are a VAP and a CSP. For a VAP, it means we are a value-added partner. We don't just sell Huawei products; we add value to the entire team that Huawei has. So we are a VAP for Huawei, and we are also a certified service partner for Huawei. So what it means is that we don't just sell to you, but we are certified in offering you after-sales support in terms of installation, as I said, commissioning, maintenance, and even troubleshooting for some of your problems that you come about. And why Huawei? In fact, our brand with Huawei is because Huawei is safe and reliable. Huawei enables higher yields for your PV systems. And in terms of their IV curve analysis and all that, Huawei offers you smart O&M portfolio, which leads to lower OPEX of your systems. So just a little bit into Jubaili Bros Solar itself. As I mentioned, the company, the Jubaili Bros Solar division was birthed in the year 2017. But as you can see, just by 2019, we have total capacity of inverter shipments close to 1,400 inverter shipped in 2019, and that amounts to about 70 megawatts globally. Let's see how we improved in 2020. In 2020, we are doing 1,800 inverters, and that is close to 93 megawatts. So you can imagine where the direction into which Jubaili Bros Solar is actually moving, and that is with you, our customers. I am very hopeful that in this year 2021, we will do more than 100 megawatts. So, to the count of the reason why we are here, and the topic is upgrading your optimizer experience. I am going to take a look at this topic from 6 main perspectives. First, we will discuss what a power optimizer is. Then we will delve into how the optimizer works in a PV system. We will also discuss how the long string design is done with the power optimizer. We will take a look at how to easily verify your installation with the power optimizer. We will also take a look at how to pair our inverters with the power optimizer, and we will finally take a look at the model performance monitoring in physical view. So these are the 6 models that I'll be focusing on before we end this webinar today. So without much ado, and with your permission, let me just move directly into it. So here, on the left of the screen, you can see how a power optimizer looks like. And this is the Huawei 450 watt optimizer. And a power optimizer is a DC-DC power electronic device attached to the PV model. Its main purpose is to do 3 things. One is to capture the maximum power point of the model. And this, and by the model, we are not talking about a string level. We are talking about model level power optimization. It allows us for a safe shutdown of the DC side of the PV system. It also enables model level monitoring, something that will not be possible without a PV optimizer. Now, on the right of the screen, you can see how the optimizers are connected in a string and to the PV inverter. So the whole connection is done by connecting the output of a model to the optimizer. So each model is connected fully, positive and negative, to the optimizer, and the optimizers are connected to each other in series, and then in series to the PV inverter, as you can see here. So you connect the negative and positive output into an optimizer, as you can see in this diagram, and then the optimizers themselves are connected in series and connected to the PV inverter. So that is how the connection of the optimizer is done. Very simple and very easy. So the optimizer that you see here on the left is actually a palm fit optimizer, very, very small, that can fit into your palm, easy to carry, robust and tight. It is the index protection rating of this optimizer is IP68. Very, very robust and rugged against the weather. Moving on from there, let's look at the basic functions of the power optimizer. What are the basic functions of the power optimizer? And here we have elaborated 5 key functions of the power optimizer. The first one is model level power optimization. So if you take a look at the graph here, this is an IV and PV graph. So you can see that the whole purpose of the optimizer is to mark out the PMP point of each model to make sure that you are harvesting as much power as you can on the model level. The second function of the optimizer is to enable model level voltage shutdown. So as soon as the PV side is de-energized, this optimizer shuts down to 0 volts to safely isolate the PV diesel side. So what we have here is that if the circuit that leads to the PV inverter becomes open, or the inverter is shut down immediately, rapidly, the optimizer shut down the system to 0 volts. And this is very, very good for DC side and also for firefighting and for other hazards that might occur on the PV diesel side, on the PV DC side. The third basic function is to enable model level physical viewing. So what you have here is the ability to physically view or monitor what is happening at the model level of your system, not at the string level, per model. So each model is able to tell you how it is functioning, and we will go into the detail of most of these basic functions in a little while. So the final basic function is to offer long string design. This allows us to oversize the DC-AC ratio larger than the traditional string design. So instead of, let's say, a maximum of 19 strings, 19 PV models in a string, with the PV optimizers, we are able to do much more than 19 PV models in a string. And how we are able to do that is part of the slides that I'll be explaining. So our next point is to take a look at how does the optimizer work in the PV system. How does the optimizer work in a PV system? Now, the optimizer works in 2 key modes. we have the back and the bypass mode. So if you take a look at this graph on my bottom right hand side, the red line is the output of the PV model, and the blue line is the output of the PV inverter. So the PV inverter works in a bypass mode. In a bypass mode, what it means is that the PV inverter is not changing the IV output of the PV model. It means it is leaving the current voltage as it is, only optimizing the power point of that. But in the back mode, what it actually does is in a back mode, what the PV optimizer actually does is to back down or to reduce the output voltage of the PV model, and by so doing, automatically increasing the output current. I just want to confirm if I can be heard. I hope everybody can hear me. Okay. Hello. I hope I am loud and clear now. Sorry for the technical interruption. Okay, so I don't know where I moved off, but I believe I could just. Okay, so I was explaining the two types of mode that the optimizer operates in. So we have the back and the bypass mode. So in the bypass mode, as you can see from this graph, as I mentioned, the lower line here is the output of the PV model, and the upper line, the blue line, is the output of the PV optimizer. So in the bypass mode, the PV optimizer do not change the current or the voltage output of the PV model. It only optimizes these values. It does not change them. But in the back mode, what it does is that it reduces the output voltage of the PV model whilst increasing the output current. So that is how it does operate. Please, it will be important for us to identify these two modes of operation. It will be very interesting for my technical explanations that we will have later on how the optimizer works. So it works in two main modes, in the bypass mode and in the back mode. So in the back mode, it's the output voltage is always lower than the input voltage, which means the output current is always higher than the output voltage. And the PV optimizer is able to work with any two-stage inverter. So moving forward from here, we come to these operations. So the optimizer wake-up process. So at night, when the PV diesel side, when the PV DC side is de-energized, these optimizers shut down to 0 voltage to protect the whole system. Now, in a wake-up process early in the morning, the M-bus communication with the PV inverter detects the PV optimizers coming online, and when enough energy builds up, they begin to shoot out voltage to this PV inverter. and the PV inverter ramps out and output accordingly. So it's a simple, straightforward process. It is not anything that you touch. It's not anything that you actually deal with. It's purely automatic. So as the PV DC side de-energizes, the PV optimizer also goes down to 0 voltage, and as it energizes in the morning, the voltage is going to ramp up. It's pretty simple. So here we were explaining the bypass process and the back process. So for the bypass process, as I explained, you can see that the IV of the PV model remains untouched through the PV optimizer. So the wattage is always the same. However, in the back operating mode, you can see that the output of the PV model, the voltage is back while the current is increased to the same preset wattage, but voltage is reduced, current is increased. And that is how the PV, this is the key operational mode of the PV optimizer, and how it is able to actually optimize our power systems as we go along. And you'll see more of it in the next slides. So let's take an example here. So here we are taking a look at a PV system with some sort of mismatch. And as we have mentioned, mismatch can come from so many other sources. It could come from leaves falling on your PV modules. It could come from shading, from soiling. It could come from birds droppings. I mean, you can't stop birds from flying over your roof. It could also come from tolerance and thermal mismatch of these PV panels. So this is an example where you can see that all the modules are connected in the same string, and they operate at the same current, because once they are in the string, the current that runs through the whole system is the same. So when there is shading on these models, we can see that the power of that model reduces. So the current that model exhibits becomes lower. If it becomes lower, since that same current is to flow through the whole string, it means that it affects the power production of the other non-affected models. So the power of that particular model falls down substantially, and the power in the other models also falls down in a manner that is not 100%. Now let's take a look at how this happens technically. So here, this is the simplification of the scenario, and here you can see that the current passing through the entire system is 8.7 amps, as you can see through these models. Now, when there is when there's any model that is soiled, shaded, or has any form of mismatch, the current in that model reduces. In this case, to 8.2. When that reduces, that affects the current that is passing through the entire string, and therefore the power of these other strings also suffer. Here we have 2.8 kilowatts. Here we are having 2.5 kilowatts or so. How do optimizers help in this situation? So here we are seeing a situation with the PV optimizer using the Huawei optimizer 450 watts. And in this situation, you can see that the power point of each model is tracked independently. For that reason, all the non-affected models are being tracked at 100%, while you can even see that incredibly, the power exhibited by the affected model has even increased. Previously, it was 44%. Currently, it is 54%. It has increased by 10%, but not only that, it has also led to an increase in all the other models, which is quite substantial. Let's take a look at the technicality of that. So here, we are seeing the same scenario, but in this instance, because of the PV optimizers, what we can see from this picture is that you see that the optimizer increases the output current to the predetermined set current here to make sure that the same current that was the case is running through the entire system. Of course, as the current is increased, the voltage is decreased. But you can see a substantial increase in the total wattage of that panel, and the wattage in all the other panels is also restored. So we have 100% panel wattage in all these ones, and then we have an incredible increase also in this one. So this is how the optimizer, and this is when the optimizer is working in a back mode, back operating mode. As I said, it would reduce the voltage, increasing the current to meet what the predetermined current states. Okay, beautifully done. Let's move on to our next. So our next model is to take a look at the long string design with the power optimizer. Long string design, we have said this earlier. What does it entail with the long string design? So let's take a look at that. Before we go, what is the optimizer compatibility with the PV model? So the optimizer, before you can apply it in your PV systems, you must make sure they are compatible with the PV model. And there are three key parameters that we look out for in each data sheet. The first one is that these PV optimizers have a maximum power capacity of 450 volts or 450 watts. So for any situation that you will use it, make sure that the wattage of the PV model is below 450 watts. Again, the maximum short circuit current of this system is 13 amps. It's 13 amps. So again, check that with the datasheet of PV model and make sure that the short circuit current of the PV model is below 13 amps. And then finally, we do a calculation to see the VOC, and we adjust it for temperature coefficient. And in this case, after calculation, we got 52.2 volts, which is still substantially lower than the maximum that we see here. The absolute maximum input voltage for the PV optimizer is 80 volts. So in all cases, you make sure that the PV model that you are going to adopt for this process is actually obeying these three parameters. That is the compatibility of the Huawei PV model, the Huawei PV optimizer for 50 watts. So moving one step forward. Now, one power optimizer fits all application scenarios. So often there are questions asked that, are you able to apply this optimizer to all PV model scenarios that we have? Yes. Once they are able to fit the three parameters that I showed you in terms of the ISC, the VOC, and the power rating, it fits all scenarios. It is compatible with the 72 cell, the 60 cell, the half-cut cell, the PEC. It is compatible with all those PV scenarios. It is compatible for all manner of installations on all types of roof. And that's why we mentioned earlier that it offers for a flexible design for residential systems, especially because currently, aesthetically, people put up roofs that are quite complex, and the PV optimizer fits all. Now, finally, this PV optimizer is compatible with the residential inverter solutions from Huawei. That is a single-phase 2 to 6 KTL and the 3-phase 3 to 10 KTL. It is also compatible with the 12, 15, 17, and 20 KTL. So, which means its compatibility runs right from the residential systems up to 20 kilowatts. And even most recently, Huawei has upgraded its 30, 36, and 40 kilowatt inverters, which has made them also compatible with the PV optimizer systems. So the interesting news is that the PV optimizers are compatible for all systems from 2 to about 40 kilowatts using the Huawei inverters. And that is great news for installers, for project developers alike. So again, moving one step forward. So the long string design, as I tried to explain earlier, the whole issue with the long string design is that we all know how traditional designs are made, where there is a calculation of the maximum number of PV models that can be in a string. With the long string design, the optimizers allow us to do strings that are longer than the traditional type. And this enables us to actually ramp up the DC to AC ratio. In some areas where there is low irradiance around the world, we can go up even up to about 200% DC to AC ratio. And I am particularly talking of areas like in Northern Europe, where irradiation is very low. You can go as much as up to 200% of the DC to AC ratio in this region. So let's take a look at what we have here. So the long string design rule with the full PV optimizer. And what we have here is that, as I mentioned, the PV optimizer is compatible with this inverters from Huawei. That's the single phase smart energy inverter from 2 to 6 kilowatt. It's also compatible with a 3-phase smart energy inverter from 3 to 10 kilowatt M1. Compatible with the 3-phase 12, 15, 17, and 20 KTL M2. And as I just mentioned, most recently, it has been made compatible with a new 30, 36, and 40 KTL M3. That is the upgraded design of that range of inverters, and they are compatible with the Huawei systems. On the table 2 on my right here, you can see the minimum and the maximum number of optimizers that we can install per string as we adopt the Huawei optimizers. So for the single phase inverters, we can do a minimum of 4 and a maximum of 25. The total DC power per string is 5 kilowatts. For the 3 to 10 ATL, we can do a minimum of 6 and a maximum of 50. For a total maximum DC power of 10 kilowatts. For the 12 to 20, similar, we can do a minimum of 6 and a maximum of 20. Also for the maximum DC power that is allowable in a string is 10 kilowatts. Now let's take a look at some technical details. So I just mentioned the traditional string and the long string design using the PV optimizer. So we all know how we do calculation for the maximum number of strings in a PV design, isn't it? So if it's a 1000 volt system, so we take the VDC and then divide it by the VOC that has been adjusted for with the temperature coefficient. In this case, using the JS 350 watt peak PV model, we are making 19 models in a string. That is normally what we would have gotten. Now, because of the fact that we use the full optimizer system, and you saw how the optimizer installation is done. So the PV models seed their power parameters to that of the optimizer. So for that reason, when we are doing the calculation for the long string, and as I just mentioned in the previous slide, that for if it's a 3-phase system, the total maximum DC power per string is what? Is 10 kilowatts. So we simply divide this 10 kilowatt by the panel wattage, and we are getting 28 strings. Now, it will be amazing. The question will be, how are you able to do this? It is very simple. We will explain it in further slides that will come. So remember the optimizer back mode, where it steps down the voltage and then steps up the current of the system. So by stepping down the voltage, it is able to accommodate more models in the string. And let's not forget, it also steps up the current of the system. But so long as the current of the system is not above the 13 amps that we stated. And again, if you do remember, we mentioned that there is compatibility that the PV models have to get with the PV optimizer. So long as it does not overstep the 13 amps, I think we are doing it. So we will see more as we go forward. This is just for purposes of illustration. So let's take a look at the long string design here, similar to the time when we treated the issue of mismatch. So here you could see that now we are having 21 panels in this system, and this is a long string design. And here, you can see what we are seeing from here. Okay, so sorry about that. So we could see from what is happening here that you can see clearly that the output of the PV optimizers have backed the system. So the current has increased, the voltage has decreased. So as the current increases and then the voltage decreases, and even you can see in this instance that the current is still 9.37 amps, which is still lower than the 30 amps that we said. So it has backed this system, but still the current is still in a safe state, and it has enabled us to increase the number of PV models in this string and make it longer than the traditional case. So, and even in this long string state, the system is still able to maximize the power point of any model that is mismatched in the system. So similarly, if the current here goes down or the voltage goes down, we are able to back it up and then back down the voltage to get something that is appreciable for the system. So it works both in traditional string state and then also in the long string state alike without any problems. So let's take a look at the application. How are we able to apply the long string design for high DC and AC oversizing? So you take a look at this roof on my left, and clearly you could see that without the optimizers, this is traditionally the maximum string length we could do. The string 2 also can give us a maximum of that. But with the longer string design, we could add more modules. We could add more modules in order to fill the spaces that are on the roof without any significant degradation in the power that the modules produces. And this will also not only increase the DC to AC ratio, but of course, it will also reduce the cost of BOS. Because the longer the strings, it means the lesser the amount of stuff we use, like cabling and all that. So the BOS cost is also reduced. DC to AC ratio is increased, mainly for areas where there is low solar irradiation. This system is absolutely necessary. So let's take a look forward. Now let's take a look at designing with PV optimizers. Here we are taking a look at the single phase optimizers from Huawei, the 2 to the 6 kilowatt inverters from Huawei. These inverters have 2 MPPTs, and each MPPT has 1 string input. So it has 2 MPPTs and 2 strings. Now remember, we said with the simple system, the maximum DC power that we can have in a string is what? Is 5 kilowatts. So these 2 MPPTs are independent MPPTs. So here, it is possible, per the optimizer design, for you to install modules in a particular MPPT that are completely different in make and type from the other MPPT. So for example, the models here could be Jinko, and the models here could be J. Just saying, without any particular attention to those particular model manufacturers. So this is suitable with these PV optimizers from Huawei. In the other case too, this is also very, very suitable, where you could connect different string lengths to different MPPTs. Remember, these MPPTs are independent of each other. So you could have the situation where you have about 20 models in MPPT 1, and let's say 70 models in MPPT 2. I explained here, you could have 20 in MPPT 1 and 2, but in case you have different brand or make of models, here you can also attach different brand or make of models, and they will all be optimized accordingly for you. So this is what the optimizers can actually achieve for us. Let us move a step forward. Again, what's the Huawei recommendation? Now, if we come to the to the higher size inverters, in this case, I think I've jumped one more step. Okay, so in this case, we are considering the 12 to 20 kilowatt inverters, and here they have 2 MPPTs. Each MPPT has 2 strings. That makes it 4 strings in all. Remember, each MPPT is completely independent of the other MPPT, which means that you could actually install different sets of units to each MPPT. For example, MPPT 1 can have a different brand or make of PV models. MPPT 2 can also have a different brand or make of PV models. All you need to ensure that the number is the same in each MPPT. So the number of strings in an MPPT should not be different. So here we have 20, for the same MPPT. For the different MPPT, we have MPPT2, you can have, let's say, 1717, and it is still recommended. What is not recommended from Huawei is this situation, where you have different number of strings connecting to the same MPPT. In this case, let's say 2017 or 1715. It is not acceptable. This is the recommended case for this purpose. And again, we will take a look at one final recommended case. So for the same 20 kilowatt inverter, we are going to do an example that in case you are sizing a system and the system is just slightly higher or slightly lower than the total DC wattage of the system. So for example, this is a 20 kilowatt inverter. In this first case, we are sizing an 18 kilowatt system, which is a system slightly lower than the 20 kilowatts. So if it's an 18 kilowatt system, you can connect, and let's all remember that the maximum DC power for each MPPT is what? Is 10 kilowatts, isn't it? So you can collect 10 kilowatts to MPPT1 and the remaining 8 kilowatts to MPPT2. Very, very acceptable. So you are doing 18 kilowatts, maximum 10 to the first MPPT, and the balance to the second MPPT. Now, in this scenario, the scenario on the right, we are assuming that you are connecting DC wattage system that is slightly higher than the inverter rating. So here, in this inverter, we are doing 24 kilowatts. Here it was 18 kilowatts. Here we are doing 24 kilowatts. It's a 24 kilowatt system. For the 24 kilowatt system, you connect the maximum to the first MPPT. That's 10 kilowatts. And then the second MPPT, remember, the balance will be more than high, because if you do 10 kilowatts here, you get 14 kilowatts, which will be more than the maximum allowable per MPPT. So you can split it into 7 for the two strings that are supposed to join the second MPPT. And it's also very, very much recommended. So if it's a lower wattage than the inverter rating, you could do it this way. If it's a higher wattage than the inverter rating, you could also do it in this manner, and it's very much acceptable. Okay, so let us wrap up quickly. Ease of installation verification, and then the safe operation mode of the inverters. That is the next topic. So here, we are taking a look at a system that has been beautifully connected with PV optimizers. As we explained, the output of each module is connected to the optimizer, and the optimizers connect with each other serially to the inverter. Now, if you want to check, it is easy for you to check whether the connection has been done properly or not. Now, the maximum impedance of each PV optimizer is 1K ohms. That is 1,000 ohms. So, you can just test the open circuit voltage and impedance of the system. If you use a voltmeter, the open circuit voltage, as you test for this system, since for one optimizer is 1K, if you have, let's say, 6 modules or 6 optimizers in this system, it should give you what? 6K average, with a tolerance level of plus or minus 10%, which means that if you should test for this system, if the impedance is anywhere within 540 to 660 volts, it means you are good and perfectly organized. Your installation is perfect. Again, the open circuit voltage of the system should always be what? 0. When the system is opened or the inverter is shut down, the optimizers ramp down the system completely to 0 volts. That is what you should also get when you inspect it. So it is easy for you to verify whether your system has been installed safely or not. Very, very easy. Okay, so let us move on to the next slide. And here we come to the National Electric Code 690.12, and this is very predominant in the US. But of course, now currently it is getting to all jurisdictions within the world, Middle East and Africa. Very soon we'll be having this rapid shutdown as a compulsory element in our PV systems. So for most systems, it is necessary, or you are required to actually have a rapid shutdown device that is connected. Without this device, we can safely tell you that the optimizers, if they are on a roof in a residential system, act as such. Because what they do is to rapidly shut down your system to 0 volts in the least possible time. Now let's take a look at the NEC rules. So here they are saying that outside the PV array boundary, that is anywhere that is outside the PV array boundary, the maximum circuit voltage that should be in such a system is 30 volts within 30 seconds as you shut down the system. 30 volts within 30 seconds. If it's in a region inside the PV boundary, the maximum voltage expected there is 80 volts in 30 seconds. Now, this is a facility that the PV optimizers can actually give you without you connecting an external rapid shutdown device. So if these are on the roof in a residential system, it is absolutely safe. You are assured that if there's any O&M or any firefighting that is to be done on the PVDC side, the system is absolutely in a safe shutdown state. So we again move on to the optimizer pairing with inverter, and this is one of the strong points of Huawei. The Huawei optimizer is actually designed to ensure that its shutdown is absolutely quick. Now, how is all achieved? You can see here there's a Huawei high silicon chipset, and this chipset is embedded in both the inverter and the Huawei PV optimizer. Now, what it does is to allow for digital cable communication systems to the PV optimizer. And these are M-bus systems, not like the traditional system that you know. So what does this chipset allow? It allows for multiple routes of communication to the inverter. Unlike traditional system where there's only one route of communication. So if that route is blocked, there's a problem. Here you have multiple routes of communication, and even if 2 or 3 of them are blocked, there are still ways that the inverter can actually communicate the PV optimizer. And this is to increase the rate of pairing, rate of shutdown in any communication system that is there in between the PV optimizer and the PV and the PV inverter. In this case, we see 1.5 minutes for a 10 kilowatt system versus 3 minutes or so for an ordinary or a traditional system. So let's take a look at pairing this optimizer in your house. And in fact, this is something that you don't have to worry at all. As these optimizers are connected in the system, the pairing happens automatically. So pairing is automatically started when both the AC or the DC side of this system is actually turned on. The pairing is done automatically, and you can see it in your Fusion Solar app. If you are using the Fusion Solar management system remotely, this pairing can be done remotely. Under the device management tab, you click optimizer set, and then the system itself would set and then recognize the optimizers on your roof. It is automatic. You don't have to worry your head too much about it at all. And these are some of the things that the chipsets are able to allow us to do easily. Finally, let us move on to the module performance monitoring in the physical view. So how to remotely monitor the performance of the modules at the module level, not at the string level. So this is module performance monitoring in physical view. So here we see an example of a PV installation on the roof, and we also see shading, right? We see some of the panels are shaded. When there is a full optimization done for this PV system, and we have been able to physically identify these optimizers in our management system. So if you are an installer and then you have an installer account, okay, you can go to the plant layout tab in the PV management system and double click on the module. Once you double click on any module in the system, you will get all this information easy at your fingertips. You have real-time information, whether it's power, current, voltage, output, or input, whether it's device information, fault information, historical information of these PV models will all be displayed to you. This is model level, not string level anymore. We are going right to the particular model, identify the history, the faults, any information that is connected to the model in terms of its KPIs. And again, one of the most beautiful advantages of a PV optimizer is in detecting arcs at the model level. Remember, majority of the PV inverters that are coming up now are having arc fault detection facilities, so they can detect arc faults, but most of them detect the arc fault at the string level. So, for example, the Huawei PV optimizers, when arc is detected at the string level, the AI is sent to the PV inverter, and then the string can shut down. Now, it will not be able to pinpoint to you what model is actually at fault, but with optimizers, with PV optimizers installed, and as I just mentioned in the previous slide, where you're able to monitor the performance of your system at the model level, you are able to identify, pinpoint, in fact, you are able to pinpoint at the model level which particular model has the arc, and you are easily able to fix it. This is something that is amazing. So how do you do this? So in the PV fixing app system, you click maintenance, and then you click optimizer disconnection detection. You wait for the system to detect, and you are able to pinpoint exactly in the system which model created the arc, where the alarm is coming from, where the fault is coming from. You are able to detect it in detail. This actually removes a lot of O&M run around the system. And finally, so then finally, what I have for you is that the PV optimizers from Huawei are not only any normal or ordinary optimizers that you can find on the market. They are optimizers that are able to give us model level viewing, allow long string, easy and quick optimizer pairing with the inverters. So all these benefits, as we explained right from the first slide, are all embedded in this small, robust palm-fit 450 second generation PV optimizer from Huawei. I hope you have enjoyed this webinar as much as I do. Sorry for the technical hitches that we had, but it's been an enjoyable moment having you around. We have come to the end of this webinar for now, but I will be happy to accept and read all your questions as you have put them in the question box, if there are any. And please, if you have any questions, you can type them in the chat area, and the questions will be brought to our notice. So I will begin to take a look at the questions now. I am here with my colleague, Mohamed Kader, our technical director from the Dubai office, and we'll begin a look at this together. Do you have a product distributor for Jubaili bros in Malaysia? And this is coming from Gunalan Ramamute. I hope I've gotten your name right. Forgive me if it's not too right. Gunalan Ramamute is asking that, do you have a product distributor for Jubaili bros in Malaysia? No, I don't think Jubaili bros has a product distributor in Malaysia. I can find out for you, but Malaysia is in the that should be close to one of our distributors. So we will get back to you the closest distributor that you can have close to Malaysia. If you're happy that there is none in Malaysia that you can contact for your products from Jubaili bros, that should not be a problem at all. Gunalan. V out less than V in. What are our currents? Yes. So I think I did try to answer that in the presentation. Yes, V out becomes less than V in the back operation mode. So as V out is reduced, the current is proportionally increased. So V out is reduced, current is increased. as against B in and I in. So that is the answer to your question. Yes, in the back mode, that actually happens. Next question. Based on your experience, do you recommend optimizer with smaller system, 3 kilowatt or 5 kilowatt or 10 kilowatt? Yes, optimizers are fantastic for smaller systems, as we explained. Even with the Huawei inverters, you can do optimizers from 2 kilowatt to 6 kilowatt single phase. Then you can do 3, 4, 5, 6, 8, 10, 3 phase. You can even do 12, 15, 17, 20, and as I just mentioned, and you can also do 30, 36, 40 kilowatts, all with optimizers. So yes, you can do 3 kilowatt, you can do 5 kilowatt, you can do 10 kilowatt with optimizers. It's a perfect match. Okay, next question. What about current? How many amps for 28 panels? Okay, yes. So you saw, as I explained, when I went to the slide that showed us the long string design, like technical of the long string design, you saw that when the long string design is big, the inverter automatically moves into a back mode throughout. So it reduces the input, the output voltage, and increases the current. But you also saw that, and I emphasized that the current was still lower than the maximum that is allowable by the PV optimizer. So it was absolutely okay. It's not something that goes overboard as against the design. So even by design parameters, the current is increased, but the current that is increased is still within a safe, allowable state that both the inverter and the PV optimizers can handle. Okay, so let's move on to next. There's another question. So what about DC cable size? We have to take consideration of current before designing the system. Yes, yes, definitely. So and that's why if you take a look at most of what we always what we try to explain, we say when the system parameters are predetermined in design, so they are predetermined in design. So in the design stage, you already know what your maximum current will be, what your maximum voltage will be, your VOC, and all those parameters are known at the design stage. So you are able to amply size the particular current cable that can match that system design. So next question, if there's any. Are optimizers cost effective in larger PV of more than 1 megawatt? I think maybe I'll let my colleague Mohamed Kader come on this one also. But yes, of course, for a 1 megawatt system, Mohamed Kader, if you can come in and explain this a little bit more better with your experience.
Hi, Sampzon. Can you confirm that I'm audible?
Yes, exactly. You are.
Okay. Usman, for a 1 megawatt or big size projects, normally an optimizer doesn't make sense because optimizers are installed normally in area where you find, shade of an hindrance or such as a tree, such as a chiller. When you have such a big project, then you normally optimize your system such that such areas are not used. But in steel, if the electricity costs are very high and you are using our smaller inverters up to 40 kilowatt, then makes sense for you to use the optimizers. For a megawatt plus PV projects, normally we recommend to use our 100 kilowatt inverters for the low voltage and 200 kilowatt for the high voltage termination PV plants, which actually doesn't support the optimizer. But yeah, till 40 kilowatt, if you have a system and a megawatt size project is there, makes sense for you based on the tariff costs that to use optimizer and use shaded regions, then definitely you can go ahead and use optimizer in such projects as well.
Beautiful. So as Kader aptly explained, I did mention that the maximum inverter usage that we have now for the optimizers is 40 kilowatts. So if you are doing a system like this, which is almost like a larger CNI or a utility scale project, those inverters will not apply, and therefore the optimizers will not be effective. Okay, next question. We can use the optimization for few panels in a string, as in this case, only the panels have a shadow. Yes, this optimizer support both partial and full optimization. That's why if you see in one of the slides, I did mention the minimum number of optimizers you can use in a string and the maximum number that you can use in a string, which means that in between those values, you could use any. If those are not your total number of PV models, that is fine. Partial optimization is also well supported. So this from Mohammed Amin logging. Yeah. So next question. Is it necessary to use optimizer for each panel in a string? Mohammed Imran, I think this is similar to the question that we have just explained, that no, it is not necessary to use for every optimizer, only that if you use for full optimizer cases, you are able to enjoy the full bouquet of benefits that the optimizer has to offer, of course, but it's not completely compulsory for you to use for all optimizers, for all panels in the string, not completely mandatory at all. So Mohammed, that is for you. Next question. We have to install optimizer with every panel. Similar question, no. It's not compulsory to do that, but you can do all if you wish, but it's not compulsory to do that. Next question. Is optimizer cost will affect on large scale up to 30 kilowatt system? Faisal Fida. So if I get the question properly, are you saying that the cost of optimizer will affect a 30 kilowatt system? So this is a minor trade-off. If you take a look at the cost of the optimizers, which I can assure you the costs are quite low, but of course to still increase your apex to some extent. But the benefits that you get from the optimizers in terms of avoiding, improving optimized power produced from PV panels that are mismatched in this situation, or if you're using it in a longer string design to actually maximize your PV production, you must take a look at the trade-off of that with the cost of the optimizers. If it absolutely makes sense for you, then it will make sense for the whole system. So I think that's what you take a look at. But ideally, we are aware that the optimizers are not too expensive, and considering how they're able to ramp up the power for you properly, I think it will be worthwhile for you to adopt it. Okay, so I think there is no further question. If there's any, we can still take one or two before we go off, but if there's no further question, I am absolutely thrilled to have you join me today. It's been an experience. Hopefully we shall meet on future webinars where we will have a better interaction on projects that we have been. Is there a question coming in? Nope. Okay. All right, so thank you. Okay, so I think there's a final question. So you recommend to use optimizer where we are facing shading and with only that panel we are under shade, or with whole string? This is from Rafi Khan. So Rafi, so if you followed closely, you would have noticed that we have already mentioned that full string optimization is not compulsory. The only thing that you have to watch out is that you are meeting the minimum number of optimizers as has been stipulated by Huawei. So, and for single phase systems between 2 to 6 kilowatts, the minimum number of optimizers that you need in a string is 4. So once you are meeting the 4 in a string, you are absolutely fine to go ahead. For 3-phase systems, the minimum optimizer is 6 optimizers in a string. So again, once you are meeting that criteria too, I believe you are also absolutely fine to move ahead in the system. So any of this should work fine for you. You could do anywhere between the minimum and the maximum, if that is okay with your design. What if optimizer gets faulty? Does it affect the whole string? Yes, when an optimizer is faulty, I think we have not discussed this also at length, but we have a warranty situation with our optimizers, and let's take note that the warranty of the optimizers are 25 years, 25 solid good years, which is as long as the warranty for most panels. So that should tell you the trust and the belief that Huawei has in these optimizers. Yeah, so if the optimizer is faulty, yes, the whole string will still work, but I think if the purpose of which that optimizer was serving will not be enjoyed, then you would have time to replace that optimizer on the string. So, for example, if that optimizer is connected on a panel that was shaded, and then it is faulty, then you should know that without the optimizer, the effect of the mismatch will be felt. Once you are able to replace it, I think that should be fine for your system. Mohammed, I don't know if there's anything you want to add in that regard.
Well, actually, when an optimizer gets faulty, it goes into bypass mode. And if you have 20 solar panels, your 19 solar panel will be connected with each other, bypassing the faulty optimizer.
Perfect scenario explained. Okay, so the other question is, what is the cost of the optimizer? Oh, beautiful question. I think if you should leave us a proper link, we don't have the cost of it, but we know the cost is very, very, very affordable. It's not too expensive. So I think if you leave us a better link, we will be able to send you a quotation of our optimizers in stock. No more questions? Good, great. So thank you everybody for joining us. Thank you all people coming from all parts of the world. It's been a pleasure having you today, and hopefully we will meet some other time. Cheers. So